This lesson concerns reconstituting dry powders that expand. Sometimes you have powder solution or powder form of the medicine that you have to give to a patient, and that powder form is not something that you can actually give them. It has to be reconstituted in liquid. Now, these particular powders actually take up some amount of volume when you add the liquid to them, and typically the liquid will be water. So we need to read a label to determine how much liquid to add to reconstitute a powdered medication that expands. So we need to calculate the dosage for the patient and determine how to relabel the remaining medicine. Because once you've done the reconstitution, you don't have just a stock solution anymore. You now have a additional different solution that is going to be used. So some medicines, as we said, are stored as a dry powder, and they have to be mixed with a liquid, often water, before they can be given to a patient. The label information provides you with choices of how you can mix them. It could be into a high strength, a moderate strength, or a weak strength. Typically, if you're giving the medication by injection, you want to get the smallest amount, so you want the strongest. And typically, if you're giving the medication by mouth, you want a larger amount, so you want the weakest. But you kind of have to go by whatever the doctor has ordered for you. Now, the basic setup for every one of these examples is your order per dose times your total volume of the liquid divided by the amount of the powder, and any conversion needed. And that gives you the give, which is the dosage, and that will be in milliliters. So for example, if you have a 20 milliliter vial of a dry drug and a label that has 100 milligrams, and you have the following instructions. You can add 4.7 ml to provide a 1,000 milligrams per 5 ml. You add 9.7 to provide 1,000 milligrams per 10 ml, or you add 14.7 milliliters to provide 1,000 milligrams per 15 ml. So obviously the strongest, a middle, and the weakest. Now the doctor's order is the patient is to receive 500 milligrams. And you can use either or any one of these three in order to be able to give you the 500 milligrams. And again, part of it is depending on if it's an injection, then you're probably going to want to use the strongest so that you're injecting the patient with the least amount of liquid. And if it's oral, you probably want to use the weakest, or at least a moderate. So in this first example, the label tells us there's 1,000 milligrams of the powder in the vial. And you want to mix it so that it becomes very concentrated. You add the 4.7 mLs. Because the powder takes up space, the total volume is actually 5 milliliters. So now you have a dosage of 1,000 milligrams within 5 mLs. Now, if you want to mix it very diluted, you would add 14.7 milliliters, which brings your total volume up to 5 mLs. So your volume of powder in this case is 0.3 ml. So no matter what amount of water you're adding, you have to add 0.3 at the end to give you the total volume. So you'll have three parts to every one of your answers. How much liquid do you need to add? Based on the mixture, what's the dosage? And then what is the new label? So you always want to put on the add line the amount of liquid you have to add to the vial to get to the appropriate concentration. In the problem, you put the total volume of the medicine after it's fixed, and then you have to create the new label, which gives the doctor's order and the give. Because you need to be able to you will likely want to reuse this once you've made this reconstitution. So in this particular example, with our 20 ml vial of a dry drug labeled with 1,000 milligrams, and we want to receive 50 milligrams or 500 milligrams. If we want to use the strongest strength, you simply multiply 500 milligrams per dose, and then you multiply it by what our strongest concentration is, which is when we added the 4.7 ml, which is 500, and the inverse, which is 500 mLs divided by 1,000 milligrams. So your milligrams cancel out, your dosage will be in mLs, and you'll basically then have 200 or 2,500 divided by 1,000. So your dosage per give will be 2.5 milliliters. So your add is 4.7 mLs. That gets you up to 5 ml total. When you do your multiplication, your dosage per give is 2.5 mLs. And you're marking it on the label now is 500 milligrams for every 2.5 ml. So if the patient's to use the moderate strength, you basically set things up exactly the same, except for instead of 5 mLs, you have 10 mLs. So your add is 9.7 mLs now to get you up to the 10 milliliters. Your dosage, instead of being 2.5, is now 5. You need twice as much because you've used essentially twice as much volume of liquid. And your mark on your label will be 500 milligrams per 5 ml. Finally, if you were using the weakest solution, again, all you're doing is replacing your ml value, in this case with 15. So you add 14.7 milliliters, your dosage is per give is now 7.5, and your label would be 50 or 500 milligrams divided by 750 milliliters. So again, the only thing that changes for the equations is the amount of volume of your total amount in the vial. And again, remember, if you added 4.7, you have to add the 0.3 to make it 5. If you added 14.7, you have to add the 0.3 to make it 15. And at that point, you just do the multiplication. So our next example, we want to have a 3.0 milliliter vial that contains 0.5 grams. And the instructions are as follows. You add 0.8 milliliters to get 0.5 grams per 1 ml, 1.8 milliliters to get 0.5 grams per 2 ml, and 2.8 milliliters to get 0.5 grams per 3 ml. And we're going to make sure that the patient receives 200 milligrams. So in this particular case, because we have the instruction given to us in grams, but the amount of what the patient needs is in milligrams, we have to add a conversion. So our dosage is 200 milligrams per dose, but now we need to convert milligrams to grams. So we do 1 gram per 1,000 milligrams. And then we try to figure out what we are going to have in terms of our inverse of our concentration. So we're going to use the strongest concentration here in the first case. So we're going to have our number of milligrams divided by 0.5 grams. So again, for the strongest, we add 0.8 ml. We read that right from the table. There's no calculations involved. It just table says you're adding 0.8 ml. So now we have 200 milligrams per dose times our conversion factor, which is 1 gram per 1,000 milligrams, times our 1 milliliter divided by 0.05 grams, which is our strongest concentration based on our table. So now we cancel out our like units. The milligrams go away, the grams go away. And now what we have is we will have 200 milliliters divided by 500, which is 0.4 ml. So we've added 0.8 ml of water as part of our reconstitution. Our dosage per give now is 0.4 ml. Remember, we just calculated our dosage as 0.4 ml. But our label is that we're going to have 200 milligrams of the active ingredient for every 0.4 ml. So remember, if you want to use the moderate or the strong, all you simply do is change the amount of milliliters to 1.8 or 2.8, which actually rolls up to 2 ml or 3 ml, because the dry solution is 0.2. Because 0.8 plus 0.2 gives you 1, 1.8 plus 0.2 gives you 2, and so on. So the only thing that changes is when your add changes, your give changes, and your label changes. So you use the same exact equation. If I was to add 1.8 mLs, my give was 0.4, but since now I've doubled it, my give will be 0.8. And if I added 2.8 mLs, I'd be tripling it, so my 0.4 would become 1.2. And our labels would change appropriately. Okay, our final example now is our doctor has ordered 2 grains of medication reconstituted at the weakest strength. So on hand, you have a vial containing 300 milligrams with the following mixing instructions, and the mixing instructions provided. Now here's a case where we have to have a conversion, because we have to convert from grains to milligrams. And there are 60 milligrams per grain. So I set it up. My dosage is 2 grains per dose, 2 grains per dose, times our conversion factor, which is 60 milligrams per grain, and then times our certain number of milliliters per 300 milligrams. Now again, there are 60 milligrams per grain, and this is the conversion factor. Now they've said that they want to use the weakest solution in this problem. So our number of mLs that we're going to be adding is 1.8 mLs. So with that, we now change and update our equation, is that we have to add an amount to make it weakest, which is going to be 1.8. So you're adding 1.8 mLs to provide the greatest solution, thus the weakest strength. And you read that directly from the table. There's no actual calculation yet. So now you want to know what's the total volume. Well, you added 1.8 mLs. Your concentration is 300 milligrams per 2 mL, so therefore your dry solution has to be 0.2. So again, reading right from the table, your weakest solution gives you a total volume of 2 mL. So your total volume will be 2 milliliters. Again, you're reading this from the table. There's no solution. There's no calculation yet. So now you need to calculate the dosage, and from that we need to go back to use our equation. So we have 2 grains per dose times our conversion factor, which is 60 milligrams per grain, times our inverse of our dosage of our stock solution, which is 2 mLs for every 300 milligrams. And that's going to be our dosage. We get rid of all of our like units, which is going to lead us to a total of 0.8 milliliters. So our current dose, our calculated dosage, is 0.8 milliliters. So our add was 1.8 ml. Our dosage was 0.8 ml. So what do we put on the label? Just what we said. The label is going to be 2 grains for 0.08 milliliters. That concludes the lesson on reconstituting dry powders that expand. Thank you.